Okay, so here we have a rhino running towards you, and you throw a ball at the rhino. And when you're given the problem, you're told that this is an elastic problem, which means that we're going to basically say the sum of the momentum initially is equal to the sum of the momentum finally, and the sum being the rhino plus the ball. And we're also going to say that the kinetic initial of the system is equal to the kinetic energy final of the system. So with this bare minimum, we're going to write two simultaneous equations. Now honestly, I've worked through this problem a few times. I don't think the physics is the hard part. I think the algebra is really ugly, even to the point you might want to do some simultaneous equations and do a solver key of some sort. So momentum is mass times velocity, so we're going to get 3,500 times 4.8 plus 0.18 times negative, to show the direction the ball is thrown, 8.35. And that's equal to 3,500 V1 plus 0.18 V2. And the V1 is the velocity of the ball after, or sorry, the V1 is the velocity of the rhino after the ball hits it, and the V2 is the velocity of the ball after it hits the rhino. So that's one equation that we can simplify slightly. And if we write out our numbers, I have them kind of written out here. You're going to end up with 93,324.98 minus 19,444.4 V1 equals V2. So you have an equation that you can solve for V2. I'm going to go ahead and write it out here. Okay, so that's one equation with two unknowns. So now we're going to go to the kinetic energy equation. Of course, it's 1/2 mv squared plus 1/2 mv squared. There's a 1/2 in front of every term, so I'm not going to write the 1/2s. Yeah, so here's my work. So 1/2 times 3,500 times 4.8 squared plus 0.18 times, it's negative 8.35, but since it's squared, that sign doesn't matter as much down here. Put it there just for good measure. Equals 3,500 V1 squared plus 0.18 V2 squared. In my mind, if you have those two equations, you've done the physics of the problem, and now we need to really just do algebra. See if I can get a new page. Look at that. All right, so if I simplify that second equation with the kinetic energy, I'm just looking at my notes, sorry to be so slow, and I do some substitution, I'll write some of the work here. Really, you should chug the numbers yourself, but you're going to get something like 40,326.725 equals 1750 V1 squared plus, and then you get kind of this gross thing. It looks like in my original work I left the 1/2 in. I really should have canceled it. 0.09 times, and then substitute the equation from up above for V2. So you're going to get 93,324 minus 19,444 V1 quantity squared, and you need to FOIL that out and distribute. What's going to happen and go through and go ahead and do your algebra here. You're going to end up with 0 equals 3, 4, 0, 2, 7, 9, 5, 2, 7. This is so much nicer in a calculator. V1 squared minus, and you have like 32, 6, 6, 3, 7, 4, 4, 1, 7. V1 minus 2, 3, 5, 2, 7.8. And you can solve for your V1 and plug in. Go through and look at this. I ended up with V1 of 4.7987. And when I plug that back in, V2 equals 17.9 meters per second. Now, to be honest with you, if I messed this up twice, I made some algebra errors, and the algebra is where the hard part is. But work through your numbers and see if you can't come up with this here. Hope that helps.